We're going to take a look at Kepler's first law, the law of orbits. It states that planets orbit in the shape of an ellipse with the sun at one focus. We're going to take a look at an ellipse. If you notice, you have two foci, with the sun being one of the foci. You have a line, this blue line going straight across. We call that the major axis. If we go from the center to the bottom, we call that the minor axis. When we look from the focus to the end of the ellipse, or from the center to the end of the ellipse, we call that the semi-major axis. All right, now we're going to take a look at our formula for eccentricity, since we know these values. And again, just remember, a planet's orbit is in the shape of an ellipse with the sun at one focus. This is referred to as an eccentricity demonstrator. It applies to the first law of Kepler, law of orbits. And E stands for eccentricity, and it equals the distance between the focus and the center divided by the semi-major axis. So C is the distance between the focus and the center, and that's our value here. And A is referred to as our semi-major axis. And as we change the distance from our center to the focus, you can see what it's doing to the value. It's actually increasing the eccentricity of our ellipse. And if we change the distance of the semi-axis, you can see that it actually moving in this direction is making the eccentricity smaller, and we move it in this direction, it's making the eccentricity, the value of A. When we change the value of A, making it larger, you can see it's making the eccentricity lower. Now, what happens if we make the eccentricity a circle, or we don't make it an ellipse, we make it a circle? Notice that a circle eccentricity is 0. It doesn't have eccentricity. It's not an ellipse. So this is showing that planets, or anything in space out there, travels in an elliptical orbit, and it's the first law of orbits of Kepler's laws. If you have any questions on the eccentricity demonstrator or Kepler's first law, please contact your teacher.